this is not a simulator. This is real hardware, and I am applying VLANs configuration in my Cisco gear using kubectl apply. And I just create a VLAN from Kubernetes. Today I'm going to show you how I turn my Cisco router into a declarative resource. In my RAV, I have a Cisco 4331, a Catalyst 3516 switch, and 3-node Kubernetes cluster with dual network interfaces. There is the problem. Kubernetes is declarative, but physical networking isn't. VLANs, ACLs, trunk port, everything is manual. So I built a Kubernetes operator that programs the router automatically. The full details are in the Medium post, but today I'm going to show you the live demo. This is the router. I get that gear for only $50. It's a Cisco 4331, and I get specifically this router because it's very cheap and also has a very important feature, that is RESTconf, that we are going to use that to define networks and ACLs from the operator. The Catalyst 3560 handles the trunk connection to the cluster. It distributes the VLANs to the Kubernetes node. Nothing fancy, just solid old school networking for less than $60. Here you could see how I define the different VLANs in a simple YAML files, and when I apply the YAML file using kubectl, you could see how the VLAN resources are created in the cluster, and then if I check the actual running config in the router, we could see the VLANs created, the 3 VLANs that I defined in the YAML file, and also the basic access list associated to those VLANs. Now I'm going to deploy a database and 2 applications. As you could see, I could define as annotation in the YAML which are going to be the VLAN associated to each resource. In this example, I'm going to deploy a Postgres database into VLAN 20, an application into VLAN 10, and another application, the same application, but in the VLAN 30. So I'm going to do a port forwarding to connect to this web application from my web browser, and as you could see, the application cannot read the database. That is because the database is in a different VLAN, and by default this operator doesn't allow the communication between VLANs. So for that, we are going to declare a policy. In this policy, we set the source, the destination, and the rules, just like a security group. So this is going to tell to the operator to create that definition as access list. And as you could see, once we create this policy, now the application on VLAN 10 can read the destination in VLAN 20. So in that way, as you could see here, the application now can read the database. Also, the operator support modification in the same resource. For example, we are going to add more port in this policy, and when we apply this policy, the operator will check the difference in the definition and in the router configuration, and it's go to apply all the changes necessary to have the same configuration in the definition and in the router. Network policies like Cilium or Calico control traffic inside the cluster, but this extends the model to the physical layer. We could finally treat networking hardware as a part of our cloud-native workflow. Hi, I'm Cesar. I'm a DevOps and also an infrastructure engineer, and I really like to build wire stuff in my laboratory. This is obviously not a production ready. This is just an experiment, okay? But I want to prove that all hardware could be also programmable, and also networking, physical networking could be also be declarative. To me, the idea of be cloud native and all those kind of stuff, it's not be only on cloud or rely in a cloud provider. It's also have the availability to create infrastructure that could be 100% declarative. And that is what we are doing right now with this Cisco Operator in Kubernetes. And before we finish, I will let you with these images about how I upgrade the router from 4 to 16 gigabits, and also the cleaning of the Cisco router, because the Cisco switch, sorry, because was very dirty and I need to clean up a lot to be usable.